Hi, welcome back. Before the break, we were dealing with 3D problems. So let's continue with another example. Okay, in this example, they tell us that in the diagram, AB is a straight line 1,500 meters long, a vertical tower 158 meters high with C, A, and B are points in the same plane, and the angle of elevation from A and B are 25 degrees and theta, and they've given us that CAB is 30 degrees. So the angle of elevation, let me just grab my pen. Okay, so the angle of elevation from A, they're talking about this angle, which is 25 degrees, belongs to the right angle triangle ACB. They're telling us the angle of elevation from B, which is theta, belongs to the triangle DCB, and that's a right angle triangle. And in both these right angle triangles, we've got 158 meters being the opposite angle. And they've given us that 1,500 is the line AB, and it belongs to this green triangle, which is our horizontal, on our horizontal plane at the base. And the only bit of information we have for this triangle is 30 and 1,500 meters, which means we only have 2 bits of information, which is not enough to solve a non-right angle triangle. But these 2 triangles, we do have enough information to solve the right angle triangles, because remember we need for this ADC, we have 2 bits of information. Here we only have 1 bit of information. We've only got 158 meters. So the triangle we can solve as it stands is triangle ACD. Okay, so determine the length of AC correct to the nearest meter. So AC belongs to that right angle triangle. And remember, we've got to use, because we want to find AC, we're going to use opposite over adjacent. So we're talking about 10. So 10 of 25 degrees will equal to 158 over what we're looking for is AC. So rearranging this, AC is equal to 158 over 10 of 25. And so AC is roughly equal to 338.8 meters. Okay, and because we now have a value for AC, let's look at the next question. Okay, AC is roughly, they did ask us to do it to the nearest meter. So 338.8 becomes 339 meters. So roughly AC is 339 meters. Okay, they want us to find the value of theta correct to the 2 decimal places. Now, to find theta, we have a bit of a problem, because we did say we don't have enough information in this triangle here. So we're going to use the base triangle to first find BC. And once we found BC using the green triangle, we can then use opposite and adjacent to find theta in triangle CDB. So let's begin by looking at this triangle here, triangle BCA, and trying to find angle BC. Remember, we found AC to be 339 meters in the previous slide. Okay, so we've got AC, we've got this side here, and we've got the angle in between. So it looks like we've got side, angle, side. So we can use Cos Rule, and we can use Cos Rule to find BC. So let's begin writing out our Cos Rule with BC squared equals to, and remember, because we're starting off with BC squared, we've got to write BC squared is equal to AC squared plus AB squared minus 2AC AB cos of CAB. Remember, again, you're starting off with BC, you're ending off with the angle across from BC. Okay, and we're going to plug in all our values that we have. So AC squared is 339. AB squared is 1,500. Okay, and then we're going to put in 339 back in here, 1,500 in here, and CAB was our 30-degree angle. Okay. Okay, so in other words, we're going to find BC squared roughly equals to about 1,484,173. And remember, again, we're looking for BC. So we're going to find the square root of that. And because the sum is continuing, we're actually going to keep that in our calculator's memory, because we're going to use that in the next step. And remember, the next step we said we're going to use this triangle to solve it, because now we have a value for BC in our calculator stored, which is this value here. Okay, so we're going to use 10 because we've got opposite over adjacent. So we're going to say tan of theta is equal to DC over BC. So it's going to equal to 158 over this, not 128, actually we're going to use 128, the value that we have in our calculator. Okay, so it's a value that's stored in our calculator. And we're going to say 128 over this value BC that we have stored in our calculator, and we're going to find shift tan of that answer. And once we do that, we're going to end up with theta equals to approximately 7,3895 degrees. We're rounding off to 2 decimal places like they asked us. So theta will equal to 77,39 degrees. Okay, so there's another question, and they've asked us to calculate the area of triangle ABC. So they want us to calculate the area of this base angle here. So that's pretty simple, because remember, we already found this to be 339 degrees. And what do we need to calculate area? We need side, angle, side. So we've got this side, we've got this angle, and we've got this side. Remember, we're always looking for a kind of a V pattern. We've got side, angle, and a side. So we can find our area. So our area will be half AC times AB times sine of the angle in between, which is 30. All that's left to do is now put in our values. AC is 339, AB is 1,500, and the sine of 30. And I think the calculator work in this one is pretty simple, so I'm not even going to do it right now. We're going to end up with our area being 127,125 meters squared. Okay, this one now involves the inclined plane. They tell us if AD is equal to 374 meters, so they're giving us the value of this side here, okay? And they're giving us the value of BD to be 1,229 meters, okay? And they want us to calculate the angle ADB. So they want us to calculate this angle here. So basically, we're dealing with the inclined plane like this. So this one here is 374 meters. This one here is 1,229 meters. And we know that this is 1,500 meters. So because we want to find this angle, we can use Cos Rule. And how can we use Cos Rule? We start off with the side across the angle we want to find. So our equation for Cos Rule is going to start off with 1,500 meters squared. Okay, so it's going to start off with 1,500 meters squared equals to that squared plus that squared, so 374 squared plus 1,229 squared minus 374 times 1,229. And remember, because we started off with 1,500, we're going to end up with the angle across it. And the angle across it is the angle we're looking to find. So the first problem again is to rearrange this. So remember, when we're rearranging this, we've done this lots of times before. Okay, so cos ADB will simply be 374 squared plus 1,229 squared minus 1,500 squared divided by that. So 2 times 374 times 1,229. Okay, and again, because we're finding cos, we'll have to put this into our calculator, and we need to put this into our calculator using the shift cos. And so it gives us an angle of 130.7176. And remember, again, we've got to round this off. So we end up with roughly around, ADB being roughly around 130.17 degrees. Okay, let's try a similar example, but this time we're going to be using variables instead of numbers. So this is a very similar question in terms of the way it looks, but here they tell us to determine the length of dB in terms of y and theta. So they want us to find the length of this side using theta and y. Let's just examine our diagram quickly just so we understand what's happening in this diagram. They've given us DC is y. Okay, theta is the angle from here, theta is the angle from here up that way in the pink triangle. Alpha and beta are part of this bigger inclined plane here. Can you see that? So alpha and beta are part of this triangle ABD, the inclined plane, the triangle that's sitting on the inclined plane. But at the moment, all they're asking us to find is dB in terms of y and theta. So we're going to be using the right angle triangle, the pink one. So basically, we've got the right angle triangle like this, and we've got theta, and we need to find dB in terms of that. And dB is the hypotenuse, so it should be easy enough to find. Okay, so let's begin. So sine of theta is equal to opposite over hypotenuse, so it's y over dB, okay? And so dB is just y over sine of theta. So we've answered that question. Pretty simple. But the reason they're asking us this is we're probably going to use this in the next part of the question. Okay, so we use the pink triangle to find dB as being y over sine of theta. The next part of the question is they want us to show that AB is equal to some complex expression, y sine alpha plus beta over sine theta sine alpha. Now that sounds complicated. Let's just look at what they're asking us to do. They want us just to find AB. Let's go and see where AB is and what information we have to solve AB. So basically, if you look at AB, AB is this one here. And AB lies in this inclined triangle ADB. So it lies in here. And in here, we already have that, and we already have that, and we've just found this side DB, which means we've got two angles, and we've got a side, we've got one matching pair of angles inside, which means definitely we can use the sine rule to solve it. Okay, so in this triangle here where we have AB, we first got to find, okay, so we have to start off. If we look at this triangle here, we've got alpha, we've got beta, and we've got this side. So we've got one pair of matching sides, so we decided we're going to use sine rule. The problem is we need to find AB, okay? So because we want to find AB, we need to have that angle across from AB. And that's easy enough to find because we've got alpha and we've got beta, and we're going to use three angles of a triangle. So that's where we're going to start off our calculation with. Okay, so again, let's recall we were trying to find AB. But if you look in this diagram, we don't have the angle across from AB, which is ADB. But it's easy enough to find because we have alpha and we have beta in the same diagram. So basically, in this diagram, we've got alpha, we've got beta, and we can find that pretty easily. Okay, we're going to use angles of a triangle to find that one. So let's begin there. And then remember, when we're using the sine rule, we already have this side, and we have a version of dB, which we found in the previous slide. So basically, first we're going to find ADB, and ADB is going to equal to 180 minus alpha plus beta. Now we're going to use the sine rule in our triangle, like we said, and because we want to find AB, we're going to start off with our sine rule with AB, and AB over the sine of the angle across it. So it's sine of 180 minus alpha plus beta, because that's the angle that's across from AB. Here's AB, and the angle across it is 180 minus alpha plus beta. And the other matching pair that we have is dB over the sine of the angle across from dB, which is alpha. Now remember, we had dB earlier, isn't it? We had dB, we found out dB in the previous slides, and we had dB was equal to y sine theta. So we're just going to substitute that for dB in the same equation. But at the same time, we're also going to realize that this sine of 180 minus beta can be simplified because this is now second quadrant. And in the second quadrant, sine is positive, so we're going to use our reduction values to say sine of 180 minus alpha plus beta simply gives us sine of alpha plus beta. And if you want, you could have put a positive, but because it's in second quadrant, we need to check the sign, and the sign is positive. Okay, so now we have an expression for AB that looks kind of complicated. AB over sine of alpha plus beta equals y over sine of theta over sine of alpha, and we need to make it look like this. So it just requires a bit of algebra to finish off, and we're just going to first multiply by sine of alpha on both sides, alpha plus beta, and there we go, we've multiplied the right-hand side by sine of alpha plus beta. And now we're going to just do a little bit of cleaning up. So this becomes y over sine of theta divided by sine of theta because of that. All right, and remember, a division can become, you invert and multiply. So it becomes times 1 over sine theta, because we're going to, this is the same as sine theta, sine alpha over 1. So it's going to become 1 over sine of alpha. And now we kind of have only multiplication. So if we multiply all the numerators, y times 1 times sine of alpha plus beta, it's going to give us y sine alpha plus beta. And the bottom, we only left with sine of theta times sine of alpha. So writing that all out, we're going to end up with y sine of alpha plus beta over sine of theta times sine of alpha. And that looks exactly like what they've asked us to prove in the first place. And that brings us to the end of this question. Okay, that brings us to the end of this lesson. Thank you for joining me. Please join me in the next lesson when we extend this concept of 3D trig problems into including using your compound identities. That's all for now. Bye.